Artemis I is the first launch of the SLS with the Orion capsule and is an unmanned mission to orbit the Moon. Its main objective is to test the Orion spacecraft, especially its heat shield during re-entry. But there were several launch delays, and space fans had to exercise patience. NASA's Space Launch System, SLS. The SLS rocket launched from Complex 39B at the Kennedy Space Center with the Orion spacecraft on board for its 25-day space mission.
6, 5, 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis I. We rise together back to the Moon and beyond.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour.
Artemis I was launched on the Block 1 variant of the Space Launch System, which consists of a core stage, 2 5-segment solid rocket boosters, SRBs, and an upper stage. The core stage uses 4 RS-25D engines, all of which have previously flown on space shuttle missions. Together, the core and boosters produce 39,000 kilonewtons, or about 4,000 metric tons of thrust at liftoff. The Orion spacecraft. After the successful launch on November 16, 2022, and entry into lunar orbit a few days later, the Orion spacecraft spent a week orbiting the Moon in a wide, sweeping orbit. On Monday, the Orion capsule also flew over the landing sites of Apollo 12 and 14, and from there will use lunar gravity as a slingshot for the 380,000-kilometer ride back to Earth. The Orion spacecraft was built by NASA and prime contractor Lockheed Martin. It can accommodate up to 4 astronauts for 21 days. Orion's glass cockpit provides fully redundant crew controls and displays. The Orion S-band communication system provides the functionality of 4 radios in one. Compared to Apollo's single flight computer, Orion has 2 simultaneously operating redundant flight computers. The new flight computer has 128,000 times more memory and is 20,000 times faster. Orion is specifically designed to carry astronauts on deep space missions farther than ever before. Therefore, it'll provide protection from solar radiation and high-speed entry into Earth's atmosphere. Orion's European service module is the powerhouse that fuels and propels the Orion spacecraft in space. Located below the crew module, it provides critical functions, including propulsion, thermal control, and electrical power generated by solar arrays. To push Orion to its destination, the service module is equipped with a total of 33 engines. 1 main engine, 8 auxiliary engines, and 24 reaction control thrusters, the same model as those used on ESA's Automated Transfer Vehicle, ATV. The service module is built by main contractor Airbus, and the primary structure of the service module, the backbone of the entire vehicle, is built by Thales Alenia Space in Italy. The solar arrays are equipped with 15,000 gallium arsenide solar cells and produce 11 kilowatts regenerable electrical power. Furthermore, Orion possesses 4 main batteries, which provides 120 volts of power when the solar arrays cannot be pointed at the Sun or in the shadow of the Earth or Moon. The heat shield is one of the most critical elements of the Orion spacecraft, protecting Orion and the astronauts as they enter Earth's atmosphere, traveling about 25,000 miles per hour and reaching temperatures of nearly 5,000 degrees Fahrenheit, about half as hot as the Sun. The outer surface is made of blocks of an ablative material called Avcoat, a reformulated version of the material used on the Apollo capsules. The Orion capsule will land in the water off the coast of San Diego on Sunday. The next flight, as early as 2024, will attempt to carry 4 astronauts around the Moon. The 3rd mission is targeted for 2025 and will feature the first lunar landing by astronauts since the Apollo Moon program ended 50 years ago this month. The Artemis missions are an immediate step towards a manned Mars landing, and many of the technologies needed for this will be tested.